The purpose of the topic for today class is Terraform modules. Terraform modules are reusable components like building blocks of your infrastructure. So when you, for example, when you are an architect designing a building, you don't have to care about, let's say, properties of the concrete, or you don't have to care about who will be driving the truck who will deliver this concrete to the building site, right? You operate on higher level of abstractions. You make certain assumptions, yeah, that someone will deliver this concrete. You will make certain assumptions like this type of concrete will have this property, will, for example, withstand this pressure and survive these temperatures, but you don't care what chemical components are used as long as it fits your purposes, right? Same situation here. As long as we are comfortable with functionality that's being delivered to us, we can consider, in fact, any system as a black box. And what's inside this black box, what's within this black box, we should not really care as long as we understand um, uh, controls of it, as long as we understand what inputs should we put and what behavior we will have, right? One more example. To drive a car, we don't have to be an expert in engineering, in mechanical engineering. We shouldn't know anything about how to create, how fuel is produced, right? We just know that when we hit the gas pedal, car accelerates. When we hit a brake pedal, car decelerates. Uh, it's hidden under all this complexity of how transmission, engine, steering wheel, everything works is hidden from us under the hood. It's below our layer of abstraction where we operate. But when we move our car to the dealership to fix something, the mechanic will operate on the lower level of the abstraction. Yeah, for a mechanic to be successful is not enough just to know that you hit gas pedal and it works, right? But again, mechanic might be an expert in some certain areas, but for example, he might not be a specialist in materials, right? He just know that this part has these characteristics. That type of fuel have these characteristics, right? And whoever creates these materials somewhere on the factory might be an expert in, I don't know, in materials, right? Again. And this chain can be infinite. But the overall goal is that overall idea everywhere, including IT, is that we're creating some package, yeah, that hides unnecessary complexity. And we're using this without worrying about how it's done internally. And by the way, very cool analogy that we covered, like Ansible is written in Python, Python is written in C. And in Ansible, when we create Ansible manifest, we don't have to care about, let's say, mm, making sure that the command run at least once, right? Or doing any checks. There are Ansible constructions that are doing this for you. And within Ansible models, there are Python scripts that are kind of orchestrating this logic. If object is not create, does not exist, create, otherwise skip, otherwise retry, and vice versa. But if we go even deeper, yeah, there is completely different world of C with these references, pointers, and all these crazy stuff that's not possible to learn, not in 21 days, not in 21,000 days. You should always remember, you have abstraction, something more complex inside, and you operate this abstraction using the interface, using the variables, using these controls, bells, whistles, and stitches. And Another thing of another benefit that it gives is standardization and ability to scale the solution. So when we create a module, for example, for a VPC, we don't have to like rewrite it again and again when we have multiple VPCs. We just call several modules once. And what we're gonna do today is we will rewrite our infrastructure into Terraform modules. We will create some modules from scratch. And before I dive into implementing this, let me know if you guys have any questions regarding this theoretical part. Yes, Ahmed.
Okay, thank you, Vlad. Are these modules, are they for instance, like libraries in Python that you can import that will do a lot of other things for you?
Yes, good
Okay.
point. Exactly, totally right. And yeah, I wanted to show it later, but since we're talking about libraries, yes, it's exactly like libraries. And in fact, there is Terraform registry. It's a location, centralized repository for Terraform modules in the form of library. And for example, later down the road, you will be using these libraries instead of creating your own from scratch. You can, for example, launch a VPC using already defined modules, so you don't have to even write module code. You can import existing one from this library, from this registry, and just use it. And this will make you extremely effective because like you are reusing results of previous work. Yes, modules are exactly like libraries. Cool. Let's then start and create some Terraform modules. So I will declare a new folder and call it modules. And first module that I'll create is a VPC. The module should live within a separate folder. In this VPC, we'll have main TF, we'll have variables TF, and we also will have outputs.tf. We will not have provider TF because provider configuration is inherited from the upper level, from the caller. It's not a good practice to include provider config within your module. And let's see what we have. Availability zones available. So, I'll take everything starting from VPC towards route table associations and all of this, and put this into here. And here we'll still use our data source later. And here we will call our module, how it's done. Module, VPC, and the module source. Source equals and path relative to this main folder to this module slash VPC. This means we need to step out of level 1 and say modules slash VPC. Let's run Terraform init and try applying it. Okay, it says something not right with our input variables. Can we guess why and what? Why occasionally, suddenly, it started to give us an error? Okay, if no one would like, I will answer this myself. We have moved this into our module, but we're still using these var files, but we did not define any variables. Let's do this. So basically what we'll need is to repeat all this. Let's run Terraform plan again. Now it says a little different error. It says argument is required. So, and here is the catch. When you create Terraform modules, you use variables, just like you had it in your TFVars, as a way to input something into a module. If main TF is your engine, variables TF will be your steering wheel, gas pedal, and brake pedal. This is how you control inputs into your module, because even though the module is the same, it still must create different VPCs with different CIDRs, with different parameters. So let's configure this. What variables do we have here? Env code equals Orlando VPC CIDR equals 10.0.0.0/16. Public CIDR equals, and it's a list, 10.0.0.0/22, 10.0.1.0/24, and 10.0.2.0/24, and private CIDR 10.0.100.0/24, 10.0.101/24, and 10.0.102.0/24. Let's run Terraform plan, Terraform apply, Terraform plan again. Still have an error, availability zone data source. So we'll have this reference to this data source inside our module, but we did not copy our data source declaration itself. And I did this actually for a purpose. Someone might argue, if you talk with someone else, some other Terraform experts, they might have different opinion. However, I strongly believe that declaring data sources inside the module is not a good practice, and it's better to just pass plain values into the module itself, so it just accepts all information that it should use and process it, but does not query by itself anything else. It will make it more like hermetic with less external dependencies, more reliable and reusable. So we need to declare one more variable called availability zones. Availability zones, okay. And put slight refactoring. This will go into here. We will remove count and forward full list of AZ names. And in here, we will replace this with var.availability zones. Replace. Very good. Let's run Terraform plan once again. Now we have errors regarding outputs. Why is that? Because we removed our old resources, packed them inside the module, and Terraform no longer have AWS subnet over here in this view, in this namespace. So for now, I'll just comment this out. And so I finish demonstrating the idea of the module itself. And after that, we'll sort these out as well. Oh no, I forgot to destroy since yesterday. I'm bankrupt. Okay. Let's destroy. Sanjeev?
Hey, man. So we can treat this model like a function, right? And you're passing arguments to it. So every time you want to pass like a different set of arguments, do we write the code uh, again and again, say module, so and so source, blah, blah, and then new values for the variable, or how does that
Yes,
work?
that's right, exactly. Like a function, like a library, class, however it can call. The concept is this. Yes, there is some abstract thing where you put values into and it produces result without you having to implement it yourself. Yes.
Okay, but we could actually pass it from Terraform itself and keep it generic instead of repeating the code for module invocation, right?
Yes, and
At runtime.
yes, I will show you that right now.
Okay,
So
thanks.
yeah, now we have same Terraform plan and 24 resources to add. And let's recall the case where we were creating like two VPCs into folders. What we alternatively could do is, for example, this VPC Orlando, VPC San Francisco. And we just changing these values over here. And we don't have to like create any new folders, copy over anything, or do any additional configuration. And of course, we don't have to create repeated code. And we can have like unlimited number of these module calls, or we can put it into count loop ourselves. And this allows you to create these building blocks of reusable configuration. Does it answer your question, Sanjeev?
Yes, Vladimir, thanks.
Okay, very good. So yes, Samira.
Do we have any compiler for this Terraform thing? I mean, like, where we can actually see line by line how the code is getting compiled and how is it pulling the data?
Compiler, there is no compiler because we're not creating binary out of this code, yes? But to a certain extent, Terraform apply itself or Terraform plan or Terraform validate, they, I would say, add as a compiler.
Okay, I'm just confused in one thing, how it is actually referring to the data. For example, we are declaring variables in a variables file, right? So how is it actually predicting that these variables are in this file? I'm not good at this coding at all, so I might.
So let's do this on the example. So which variable is in this setup, in this case, you are not sure about?
Right. See all these environment code. These are the variables, right?
Yes, these are the variables that are declared inside the module. Over here. So pay attention. These variables .tf. Let me close all this so it don't confuse you. That's this file. Whatever declared in this file, variables tf, is accepted as an, hold on a second, once again, yeah. Whatever declared here in this variable TF within this, again, over here, modules VPC, is accepted over here as a parameter. You kind of building your custom resource, and the property you want to declare for this custom resource should be declared, should be written here in these modules as a variable inside the module.
Okay. And before we were actually using this terraform.tfvars file to actually give the values to these variables, right?
No, these are different variables. So these variables are on one level, and these variables are something that lives kind of outside. So yeah, since this question was asked already, let me do. I wanted to demonstrate this anyways, but let's do this. Let's do some diagramming then. You can see this as a tree. So, and a module is a leaf on this tree. So it will be module slash VPC. We'll have level 1. So here's what will happen. So we declare our variables in Terraform TF-vars. And let's be explicit regarding path. Level 1, Terraform.tf-vars. Okay. Then this variable can happen because it is declared in level 1 variables.tf. Something like that. And they are visible over here in scope of like level 1, let's say in level 1 main.tf. Then in VPC module, we are declaring another variables. VPC slash variables. And they are passed from level 1. And we decide what we will provide over here, right? It's doing like this. And within this module slash VPC, it's completely different, I would say, namespace, completely different vision, visibility level. So whatever variable is described over here and passed through VPC slash variables TF from level 1 main TF does not equal to this variable, these variables TF.
Oh, okay. What if there are any duplicate variables?
Duplicate between what and what? Between this and this?
Yeah.
So let me show you that. So even though we have declared these variables and have these Terraform TF-vars, right now we are not using any of them because everything is hard-coded simply, right? I can just do that. Disable this, disable that, and it will still work. Why? Because it's already written hard-coded directly here without any variables in the module. Over here. It will just take this. It will not care about what we specified in our TF-vars because we have explicitly written over here. I don't know, New York. And when we run Terraform plan, it will give us not our TF-vars. Why it is saying that? It will give not our TF-vars, but it will give whatever we specified over here. Terraform,
got it.
Terraform plan. Here it is, New York, right? And having said that, yeah, let's return everything as we had. And over here, I don't want to have this hard-coded. I will also use this time these variables that are taken from tf_vars file, and basically repeat everything. Var env code, var vpc CIDR, var public CIDR, var dot private CIDR. Save. And also outputs. We still need them, but how we gonna reference these resources that no longer exist? Easy. Same thing that variables are gas pedal of our Terraform module. The outputs.tf is speedometer. Outputs.tf, whatever we declare within the module in this outputs.tf file, in this case our exact copy, we can reference as a property of a module. So instead of AWS subnet public ID, we could have module.vpc. And right now I'm editing this outputs.tf. This one remains the same. Module VPC and the name of this output, public subnet ID. Module VPC dot private subnet ID. Also the same for our VPC ID, and also the same for our VPC CIDR. Oh no. Yeah, now it's good. Because I forgot to save and I have to type everything manually again. Let's run Terraform plan. Module VPC CIDR. And I need to rename this back into just VPC. Terraform init. Terraform apply. Yes. And while it is applying, we can move forward and repeat the same. Yes, of course, answer all your questions, but after that, we will repeat the same for our instance, load balancer, and auto scaling and whatnot. Sanjeev, yes.
Yeah, so Vladimir, so you have concept functions in programming languages where you pass default arguments, right? So is there
Default-
something similar for the module?
Default arguments? Yes, there is an option to specify default. You can write default
in the variable,
like something, yeah. I don't like, again, that's my subjective opinion. A lot of people might argue with me, but I'm trying to avoid providing defaults because, like, due to different reasons. I'm trying to specify everything explicitly rather than implicitly through defaults.
Okay. Thank you.
Okay, yeah, then let's move forward, create a couple more modules. We'll have ASG for auto scaling and load balancer for load balancer. What should we start with? Probably. Yeah, never mind. Let's just start. Yes, Sabina.
Sorry, when you say you like providing values to variables explicitly, do you mean providing them as like exporting variables?
No. What I'm saying is that you can, for example, specify not here.
The .var files.
No, let me explain this. We can specify them like this: default equals something, and never specify it over here. This means it will pick up this default. This means implicit. This means we are omitting, we are not telling it directly how it should be, and making assumptions that it will pick default value and this default value will be used. This is the strategy that I don't like, because first of all, you should remember what was your default value, or you have to always go and check over here. And also, you will not understand whether this default value was not specified intentionally, or someone just forgot that there is a default. There are exceptions, like for example, port 22 or port 80, like commonly known ports. But again, my philosophy is I'd rather specify explicitly versus implicitly and never use defaults at all, or at least like try not using defaults as much as I can. Okay, same here. Let's move forward. Main.tf, variables.tf, and outputs.tf. And whatever we have in instance.tf, probably without Amazon AMI. So why we're not picking Amazon AMI data source? Because we would like an ability to create like any AMI from this using this module, not just Amazon Linux AMI. And also IAM will go here as well. And let's have it as a single file for consistency. User data will go here as well. And we obviously probably need some variables. So what we have here in the code, equals or lambda. Let's have different. Let's say we have our VPC, which is our lambda, yeah, by location, and our ASG and load balancer, let's say, will be by purpose. Let's say finance. Load balancer security group, environment codes. We'll need a variable for AMI ID. And this will be a reference to our data source. We'll need this as a variable as well, because it will be taken from the separate module. We'll need private subnet ID. And will be taken from here. Let me immediately replace this in the source file. Or let's subnet ID. This one will be var target group IRN. This one will be IMI ID. And yeah, then let's move forward. Environment code, YAM role, probably we are quite good. We'll need target group. So then let's move forward to our load balancer and repeat similar steps. main.tf, variables.tf, and outputs.tf. Our load balancer code will go to main. And here we will declare module load LB for load balancer, source equals module/LB, and variables. Which variables do we need in this case? In the code, VPC ID, we will immediately replace it with this over here, and this one will be replaced with a variable var VPC underscore ID. In the code, load balancer, public subnet ID. Yeah, and this one looks fine. And the NV code will be finance. Very good. Now we need to output something. So we will take the what we needed. Hold on a second. Make sure I don't mess up anything. So in our autoscaling group, we need target group IRN. It will be module, load balancer, target group IRN. This means we need to declare these in outputs of our load balancer. Output, target group IRN. And value will be AWS target group, load balancer, IRN. Let's make sure it is called main. Main.IRN. And also declare the module variables as well. We've called them here, but we also need to declare them within the module itself. And into our auto scaling group as well. Oh, it was a lot, and hopefully I did not mess up things, but I'm sure I'm wrong. And the best way to learn Terraform is to break something and learn how to fix it. So hopefully we'll get some errors. C modules typo. Yeah, thank you, Sanjeev. Let's check that. Where it is. C module. Sanjeev, could you please tell me exactly where my typo is? Yes.
Line
please.
2, line 2.
Line
In the
2.
same file that you opened.
Okay, modules. This one, modules, yeah. And let's rename this into auto scaling. It will be more descriptive. Yeah, it says we need to run Terraform init. AWS target group main IRN. Resource AWS does not been declared in module LB. Let's check this. So we have our outputs, which says AWS target group main. And we have our, yeah, it's AWS LB target group, not target group. Security group, AWS security group, load balancer ID. Okay, we need to pass AWS security group ID as well to our auto scaling group. This means variable. LB security group. This means we'll have a variable call into autoscaling TF. LB security group equals module LB security group ID. Let's have it more explicit, LB security group ID. And in outputs, we need to declare it as well. We have it in outputs. We had it in our autoscaling.tf. LB security group ID. Let's try running this again. And we also need a variable in our autoscaling group. Over here, AWS security group load balancer. Instead of this, should have var dot base security group ID. Yeah, this one I'll remove. Come on. Yeah, not that file, this one. No attribute security group ID. Output, yeah, we need to make sure this output matches to how we call it over here. Yeah, it's LB security group ID. On time? Yeah, another error. Finally, some progress. And we forgot to add one more variable. It also requires VPC ID, and our data source remain on level 2, not within the module. So it requires VPC ID, I believe, autoscaling. VPC ID equals reference to our VPC ID data source from level 1. And here we declare variable VPC ID and replace here our data source with var.vpcid. VPC ID base. Let's run one more final time. Oh, not final. Cool. One more thing. It doesn't like user data.sh. It says this file not found. Why is that? Because we're still running it from here, and the file function expects user data be to still here. It's such a relative path. And when we do it like this, we can most likely, yeah, it now suggesting us to create these resources. But we rather keep this file here. And how should we fix that? Very easy. We can either provide full path, or there is some special, I would say, syntax sugar. I'd call it this way. Some trick, and let me find it in my notes, and I will demonstrate it to you. And that's the one. So what it says is that whatever directory you're in, provide this path and append user data sh. So this will exactly map to module/asg/user data sh. Let's try this one more time. I forgot to save. While it is creating, any questions, any thoughts? Yes, Sanjeev.
Hey, Vanazip. So you demonstrated how to convert the existing code to modules, right? Rewrite them as modules in Terraform. So about the resources, if you want to retain the state of the resources, then um, that should be possible also, right? Just asking.
Yes. You mean you have some existing resources managed using existing Terraform, and
Right.
you want to refactor into modules, but you can't afford luxury of recreating everything, right?
Exactly.
Very good question, and it's a very, I would say, typical case in real world scenarios. Yes, obviously, it is possible. Remember, I was demonstrating these Terraform state management commands. State RM, or there is also Terraform state MV, which will move resources within a state file. So this is where you should go. We don't have time to demonstrate this use case. We only have 3 minutes left, but we can do this. We are moving slightly ahead, and we'll have some spare sessions closer to the end. I will demonstrate this with the rest of like some advanced concepts. But you can practice it yourself. But the key is Terraform state move. That's the command that will be used.
Okay. Thank you.
And always, every time we make some changes, every time we add a new feature or like refactor anything, we should always check and make sure the infrastructure itself is working. And just having successful Terraform apply is not enough. We must be sure that, let's say, if we're serving a web application, the page is responding with the proper response and gives us whatever we have. So I have my load balancer URL over here. And the moment of truth. Yeah, it is still working. And when you do your home tasks, make sure there is no regression in your app and it's still operating well. That's very important to always have. With that, I open the floor for the questions in case anyone have anything. Don't forget to commit everything. Obviously, don't forget to run Terraform destroy. With that, yeah, let me know.